All right, so we're moving into slope-intercept form. So we talked about we talked about standard form. Standard form we said was ax plus by equals c, right? Slope-intercept form is going to be, it's going to be y equals mx plus b. We'll get to that in a minute, but before we even get to slope-intercept form, remember I said that standard form and slope-intercept form is like if you had a dollar bill and you converted a dollar bill to 4 quarters. 4 quarters and $1 a bill are the same thing. It's just in different forms. So when we learn slope-intercept form, we are learning the same thing, but just how to write it in a different form. Before we get to slope-intercept form, we need to talk about slope. Okay? So it says slope. First of all, when you hear that word slope, we've talked about this before in class, but I'll ask again, what do you think of when you hear the word slope? Robert?
Not straight.
I wouldn't say not straight. Yep.
Horizontal.
Incline. Incline. I like that word the best. Incline.
Smart.
Slope refers to steepness, how steep something is, right? All right, so slope means how steep a line is. If you look at this line here, do you notice how they put 2 points on the line? We're going to use something. We can't just say, oh, that line is kind of steep, or oh, it's very steep. That's not good enough. We need to use a number. And the way we calculate how steep a line is by using something called rise over run. Rise refers to how something goes up and down. It is possible to rise down. I know that sounds weird, but rising down just means you're rising a negative number. So rising means up and down. Running means left and right. So rising is referring to the y-axis. Doesn't y mean up and down? And running refers to the x-axis, left and right. Okay, so what we're going to do is first, another thing. I know this is also going to sound weird, but this letter M stands for slope. So anytime you hear the word, see the letter M in an equation, it's going to mean slope. Yes?
Is that why, like, mx?
Exactly. Y equals mx plus b. The M part, yes, absolutely is talking about the slope. So to find the slope, we do like we just said, rise over run. Do you see how that's a fraction? We're going to put the rise in the what part of the fraction?
The numerator.
The numerator, good, the upstairs. And then the run goes in the denominator, downstairs, okay? Now, that's the same thing as saying the change in y divided by the change in x. That should sound familiar because didn't we find the change in y divided by the change in x when we are looking at tables and determining if they're linear or not? Okay, now this other thing right here, this y2 minus y1 divided by x2 minus x1, that's called the slope formula, and we're going to learn more about that another class. But that also is referring to slope. So, a couple things. First of all, I gave you a couple little notes. I said up top, I said pick 2 perfect points and do the rise over the run. We'll do that in a minute. But it says rising up means a positive number and rising down means a negative number. If you run to the right, that's a positive number, and if you run to the left, that's a negative number. That's going to become important when we're trying to figure out the slope of a line. Okay? So, if we look at these graphs, part A, find the slope. It says describe. That means the same thing. Describe the slope means is it positive or negative. Right this second, I'm more concerned about this part here that says find the slope. So let's talk about how we find the slope. Do you see how on this line they have given us 2 perfect points? They don't always give those to you. Sometimes you would have to go in and find 2 perfect points, but when they give them to you, it's nice and easy. Now, they also gave you the ordered pairs because you could use a formula too, which we will talk about, like I said, another day. For now, we're going to do, what did I say we do to find the slope of a line? Rise over run. So the rise is the numerator. I'm going to use red for that. The run is the denominator. All right, so what I'm going to do from this point, it doesn't matter which point you start with. So I'm going to start with the bottom point. If I want to figure out how I would get from this bottom point to this top point, the first thing I always do is figure out the rise. Okay, I see kids do this a lot where they start doing this. Why is that not correct? If you go that way, you're doing the run first, right? We're always doing the rise first. So we're going to figure out from the bottom point to the top point, it rises 1, 2, 3, 4 boxes, right? Now, if it goes up, which it did, didn't it go up 4 boxes? We said going up is positive, right? Yes, I'm listening. All right, so we figured out the rise was 4. It went up 4 boxes. And then how many does it run to get to that other point? 1, 2, 3, 4, 5, 6. And it went to the right, which is also positive, right? So both the 4 and the 6 are positive numbers. Now, I want you to leave the slope as a fraction, but I do need you to simplify it. So what does 4/6 simplify to? 2 over 3, right? What that means is, look, if I were to go back to this line and go to that first point, and if I were to go up 2 over 1, 2, 3, aren't I at another point? And if I were to go up 2 and over 1, 2, 3, aren't I at another point? That means that that slope is up 2 over to the right 3. I could keep doing that. Up 2 over to the right 3. Up 2 over to the right 3. That's going to continue to give me points that would be on that line. All right. I want you guys to try part B. You're finding the slope. All right, so on this one, you'll see the 2 points that they've provided. Again, they don't always provide points for you. If they don't, you have to go and find 2 perfect points. You'll zoom in and you'll find 2 perfect points. But they've given you perfect points. Now, it doesn't matter which one you start with. If you start with the top one, am I going to start by going over? No. That's the run. I always worry about the rise. I know it sounds weird, but if you start at that top point, how would you have to go to get to that bottom point? Down. 1, 2, 3, right? Which would be negative as the run. As the rise. And the run would be to the right 2 boxes, which is positive. A negative divided by a positive is going to be what? A negative, right? So negative, now, I don't want to turn that into a mixed number. I know it's improper. I want you to leave it improper, because if you turn it into a mixed number, is that going to help you figure out the rise and the run? No, I want to know the rise and the run. So I'm going to call it negative 3 over 2. The fraction itself is negative. The slope of that line is a negative slope, whereas the first one has a positive slope. Now, let's pretend instead of starting with this top one, let's say we started with the bottom one. If we started with this bottom point, what would you have to do to get to this top point? Go up 3, which is positive, right? And then I'd have to go over to the left 2, which is negative. Isn't 3 over negative 2 going to be the same as negative 3 over positive 2? A positive divided by a negative is the same as a negative divided by a positive. Aren't these both equivalent to negative 3 over 2?
No.
All right, so either way you do it, you get negative 3 over 2 as your slope, okay? So, be careful. This is what I had to tell my other class. I want you to always look at the x-axis and the y-axis, because if the x-axis was going by, let's say this was going by 2s instead of 1s. If it said something like this, 2, I messed that up. Let's say this said 2 and then 4 and then 6. When you go over a box, if it's really going by 2s, don't you have to count by 2s every time you move over one? So always check to see what the x-axis and the y-axis is going by, because if it's going by something other than 1s, then you have to count differently. All right, so what if you were given a table and it asked you to find the slope? Now, I'm telling you right now that these numbers in this table are creating what we call ordered pairs, right? All of these are ordered pairs. And if you read the directions, it tells you that all of these points lie on a line. If they all lie on a line, that means they are forming a line. What kind of function forms a line? A linear function. So they're telling you that all of these tables are linear tables, or tables that represent linear functions. And they're giving you all these ordered pairs. They're asking you to find the slope. I don't want you to sit there and graph all those points. Nobody wants to go and graph 4, 20 and 7, 14 and so on and so on. Instead, we're going to use what we've used before, the change in y divided by the change in x. Didn't we say y represents the rise and x represents the run? When you find the change in the y, you're finding the rise. When you find the change in the x, you are finding the run without having to graph it. So if we look at this first table, when I say the change in y, I mean I'm going to look at the y column. The first y value is 20. The second y value is 14. How did that change? From 20 to 14, what happened? We subtracted what? -6. So the numerator would be -6. The denominator is going to be how the x's change. From 4 to 7, it went up +3. So I don't need to write plus. I could just write +3. That is a fraction. -6 divided by +3 means m is equal to, what does -6 divided by 3 equals? It's a whole number. -2. So the slope is -2. And because they already told you that this is a linear function, that's going to keep happening. You're going to keep doing the change in, if you did the change in y divided by the change in x, you'd see that it kept simplifying to -2. Okay, we're going to look at this one, part B. If you look first, what are we going to find? The change in the what? Y. So if we look at the y column, it doesn't, from 2 to 2, it doesn't change at all. It's +0, right? So the numerator is 0. The denominator from -1 to +1 is, no, 2, right? So 0 over 2, what does that equal?
0.
Thank you. The slope is 0. What kind of lines have 0 slope?
Intercept.
Think about when I say slope means steepness. What kind of lines have 0 steepness? All lines are straight. No.
Vertical.
Vertical has lots of steepness. Horizontal lines have 0 steepness. If you look right now, look over here. If you look, you'll see this is a horizontal line. There's no steepness. If you were to start right here, if you had a pair of rollerblades on, and there was no wind, and you stood right here, and you didn't do anything, are you gonna move? No. If you were on something like this and you started right here, gravity would pull you down. There's lots of steepness on a vertical line. On a horizontal line, there is 0 steepness. So this is definitely representing a horizontal line. That's not the question, but I want you to realize that this would be a horizontal line. And if you remember, when you have a horizontal line, if you wanted to write an equation for a horizontal line, it would be y equals a number. What number do you think it would say here? Y equals?
This is geometry.
Good. Yeah, for those of you that said 2, that's correct. Do you see how all the y values are 2? So now that wasn't what the question asked, but I'm asking you about what the equation would be. This would be a horizontal line with the equation being y equals 2, and that is telling me that the slope is 0. There is no steepness. If you look at this one, the change in y from -3 to 0 is up 3, right? +3. So that's the numerator. The denominator is +0, right? Now, is 3 divided by 0 going to give you 0? No. I'm going to show you what my algebra teacher showed me when I was in algebra. Yeah.
That should be italic.
Versus. Do you see how in the word okay, the 0 is in the numerator? In this one that says no, the 0 is in the denominator. If the 0 is in, just let me finish. If the 0 is in the numerator, that's okay. 0 in the numerator just means it's going to equal 0. If the 0 is in the denominator, that's a no-no. We can't say that equals 0. There is no answer. And what we say is the slope is undefined. It's so steep, we can't define it. All right, so are we understanding what the difference is? What kind of line has undefined slope? What do you think that kind of line is going to be?
No line.
Not no line.
Undefined.
A vertical line. Vertical lines have slope of undefined, and horizontal lines have a slope of 0. Okay, that's the difference. Okay? Now, I put a little note here that said slope and constant rate of change mean the same thing. This is a little summary right here that shows you lines that have positive slope are going to go like this. Do you see how this line is going up and over to the right? Whereas this one, if you look at this one right here, this has a negative slope. If you start at the beginning, isn't it going down and to the right? Okay. Then this one we said was a horizontal line, which we said has a slope of 0. And this one is a vertical line, which means has a slope of what we call undefined. Okay.
Wait, go back up. The last one.
All right. So if you look, we haven't even talked about what actually slope-intercept form is. Slope-intercept form, the same way that standard form is ax plus by equals c. Well, slope-intercept form is right here, y equals mx plus b. Okay? The y and the x will stay y and x, but the m and the b will be replaced with numbers. All right, so if you look at this equation, you'll see that it's telling you that the m part means slope. So that m will be replaced with a number, and that number will be whatever the slope is of the line. The b part is what we call the y-intercept, and we talked about y-intercepts already. Y-intercepts is the spot where the line crosses the y-axis, right? So if it's crossing over at 3, then the y-intercept would be 3. If it's crossing over at -9, then the y-intercept would be -9. So the slope, which we've learned how to calculate the slope, that's the m part. The b part is the y-intercept. So, for example, if you're given an equation, y equals 3x minus 4, and I asked you what is the slope, which remember, that is the m. What would you say the slope of this equation is? 3, okay? It's not the x, it's just the number in front of the x. If I asked you what's the b, meaning the y-intercept, what is the y-intercept here? -4. All right, let's look at c. I'll go back to b in a minute. What is the slope of this equation? -1/2. What's the b, the y-intercept here? +5, right? This is the b value. This is the m value. I know this isn't there, but I'm going to write this. What if it said something like this? What do you think the slope would be here? 1. If there is no number in front of the x, that means it's really an imaginary 1. 1x is the same thing as that, as slope. 1x is the same thing as just saying x.
So whatever's in front of the x is just...
Whatever is in front of the x is the slope. The slope is never x. It's what's in front of the x. If you don't see anything in front of the x, that means the slope is 1. What if it said -x? What would the slope then be? -1. All right? All right, let's look at b. b, is there an x in this equation? No, and we just said the slope was whatever number is in front of x, but there is no x. So therefore, there is no slope. What does that mean the slope is? No, well, m is what we use to represent 0. What would the y-intercept be then?
6.5.
That constant is always the y-intercept. The slope, technically, y equals 6.5 is like saying y equals 0x plus 6.5. All right, so like I was saying, if you have y equals a number, really it means 0x. What is 0 times anything? So that's why they don't write it, because 0x, I don't need to write 0x. They would just leave it at 6.5. So the y-intercept is 6.5, the slope is 0, which means, isn't this a horizontal line at 6.5 because it has a slope of 0, right? All right, the last part of this is graphing it, okay? If I asked you to graph, and I give you an equation, the first thing you have to look at is what form is this equation in? We learned how to graph things when they are in standard form, but is this in standard form?
No.
Definitely not, right? What form is this in?
Slope-intercept.
Slope-intercept form. Isn't it say y all by itself equals something times x plus something? That's slope-intercept form, right? Y equals mx plus b. Standard form would have to be something times x plus something times y equals a number. So when it's in slope-intercept form, these are our steps, okay? The first thing you're going to do is look at the equation and figure out what the slope is and what the y-intercept is. So the m, the slope is -2, right? And the y-intercept is +2. Then what you're going to do when we actually go to graph it, you're going to first graph the y-intercept, meaning we just said the b was +2, which is the y-intercept. So on the y-axis, we're going to go to the number we just said, which was +2, and we're going to put a point. Then the next thing we're going to do is we're going to use the slope to graph more points. Remember, 1 point is not enough to form a line. You need at least 2 points. So what did we say the slope was in this equation? -2. Remember we said slope is rise over run, right? Which is a fraction. Is -2 a fraction? Can we make it a fraction? We could put it over 1. Doesn't that tell me that the rise is -2 and the run is +1? So what that means is we're going to go to that y-intercept that we already graphed, and we're going to rise -2. What does it mean to rise -2? Go down 2, and running 1, +1 means go 1 to the right. Now these little markings I put, you really shouldn't put. But if I go down 2 and over 1 to the right, aren't I right here? Right? I went down 2 and over 1 to the right. I could keep doing that. I could keep going down 2 and over 1 to the right. And you'll see it continues to be a point that would be on that line. You could also do the opposite, because +2 over -1 is also equal to -2. So I could go back to that y-intercept and do the opposite. Go up 2 and over 1 to the left. Do you see how that would still be a point on the line? Doesn't that, if I were to have a ruler, wouldn't I be able to connect all these lines perfectly with a ruler? Okay, I didn't do it very well, but you could, and I'd put arrows on either end, right? All right, so we're going to do some more practice with graphing. So if we look at this equation on number 7, you'll see it's in slope-intercept form still, because it says y equals 4x minus 4. So the m is +4, the number in front of x, and the y-intercept is -4, the number at the end. So this is my y-intercept, -4, and this is my slope, +4. So the first thing I do is graph that y-intercept. So the y-intercept is at -4. So I go to -4 on the y-axis, which is down here, right? -4. Okay, I put a point. The next thing I do is I use the slope. Well, the slope is 4, +4, which is not a fraction right now. So I'm going to make it a fraction by writing it as 4 over 1, which means the rise is 4, positive. The run is +1. So if I go to that y-intercept, that's my starting point, and I rise 4, I go up 4 boxes, 1, 2, 3, 4, and I run 1 to the right, that would be right there. I could keep doing that. I could keep going up 1, 2, 3, 4 over 1 to the right. I could also go back to that starting point and do the opposite, because positive 4 over positive 1 is the same thing as saying negative 4 over negative 1, because a negative divided by a negative is also a positive. So I could go back to that point, that blue point, that was my y-intercept, and go down 4, 1, 2, 3, 4, and over to the left one, which would be negative. And you could see that you could connect all these points and form a line. And I'm going to put arrows to show that it keeps going in both directions. Okay? The next one, we start always with the y-intercept. Well, the y-intercept here is positive 3. So I'm going to put a point here at positive 3. My slope is negative 1/2. That means I could either write it as negative 1 over positive 2, or I could write it as positive 1 over negative 2. They can't both be negative. If they both are negative, then it would be it would equal a positive, and it's not supposed to be negative. So the reason I wrote it both ways is because on this one, the rise is negative and the run is positive. So I would go down 1 and over to the right 2, which would be right here. And I could do that a couple times. Down 1, over to the right 2, down 1, over to the right 2, and so on. But I also could go the opposite direction, which means go up 1 and to the left 2. So if I go back to that starting point, that blue point, and I go up 1 and over to the left 2, you could see that it would continue to be points on this line. And all I'm doing is going up 1 and over 2 to the left. And you could see how it continues to make points that would be on this line. And I'll connect them, I'll draw arrows, and that's the line. Okay? Now, the last thing we're going to do is the word problem. It says a submersible, which is a fancy way of saying a submarine. A submarine is exploring the ocean floor and begins to ascend. Ascend means to come up to the surface. Descend means to go down. So it's ascending, it's going up to the surface. The elevation is h, that's what they're using h for, in feet, of the submarine is modeled by the function h of t, which is a fancy way of saying y, is equal to 650 t minus 1300, where t represents the time in minutes since the submarine began to ascend. So it says, what is the y-intercept? So even though it's written fancy, if I replace the h of t with y and the t with x, it would say this: y equals 650 t minus 1300. Which you could see is written in slope-intercept form. So if I asked you what's the y-intercept, well, right here, this is in the B spot, right? So the y-intercept is negative 1300. What does it represent? It's negative, which means it's less than 0. What that's representing is the starting point. Where did the submarine start? It started 1,300 feet below the sea level. So under the water, right? So 1,300 below the water, right? Which is called the starting point. That's the starting point. The y-intercept is always the starting point. Now, the submarine is going up. It's reaching the surface. And you can see it's going at a rate of 650 feet per minute, right? They're talking about minutes. So what is the slope? Well, the slope is that 650, positive 650. What does it represent? Well, what we just said, it represents that the submarine, I'll put sub for submarine, is going 650 feet up, or I should say the submarine is going up. Let me fix that. The submarine is going up 650 feet per minute. That's what that's representing. That's the constant rate of change.